VIP. Let's kick it.
Ice, ice, baby.
And for our first guest, the infamous, the round down, pound man down from the underground, Ice Cube. First question, what's your vapor pressure?
0.03 ATM. I'm not talking about where I get my money from. Next question.
Okay, can you tell me your melting point?
0 degrees Celsius. The whole Celsius is based off me.
I feel that. How about your boiling point?
100 degrees Celsius.
Next question. What's your enthalpy of fusion?
My enthalpy of fusion is 334 joules per gram.
Now, what is enthalpy of fusion?
It's the energy required to go from a solid to a liquid.
Thank you. Now, how is your electrical conductivity?
Not very good,
Why?
because I'm done with those ions passing through my structure.
Can you tell me about your brittleness?
I'm very brittle,
Why?
because of my hydrogen bonds form a hexagon.
Next question. How hard are you?
I'm mildly hard,
Why?
because those rich minerals in my structure.
Next question. How malleable and ductile are you?
Not at all.
Why?
I already told you I was brittle.
Sorry. Now, before we end things here, is there anything you'd like to add?
I'm actually the only compound known in the universe to be less dense in the solid stage than in the liquid stage.
Yeah, on that part. We'll just end it
AP
with,
Bio reference.
And for our final guest, I'd like to introduce the man of the hour, the driest of the ice, Mr. Dry Ice.
Great to be here today, Geo.
Yeah, thanks for being here, man. So I'm gonna ask you a series of questions. First off, being
Awesome.
can you tell me about your vapor pressure?
Oh yeah, definitely. Ever since I was a youngin', my vapor pressure's been 5.73 megapascals. That's for 20 degrees Celsius. It's great. It's awesome.
I heard you don't really have a melting point. Is that true?
Yeah, that's right. I actually turned directly from a solid to a gas. It's called sublimation, and that happens at around 56.6 Celsius. It's a great temperature for sublimation. Definitely one of my favorites.
Yeah, no, same here. Definitely. How about, so I heard you don't have a boiling point either, is that correct?
Yeah, no. Boiling point, it's from that liquid to the gas. I don't even have a liquid state. So,
I get that, man.
Like,
One thing, can you tell me about your enthalpy of fusion?
you mean enthalpy of sublimation? Because
Yes.
Alright, well, my enthalpy of sublimation is 571 kilojoules per kilogram, or 25.2 kilojoules per mole.
Why?
Oh! Why, it is because of my crystal lattice structure.
Can you tell me how brittle you are?
Oh, I'm actually really, really brittle. I'm one of the most brittle people I know. It's great being brittle.
But why?
I think it's because of my crystal lattice structure.
Okay, so this question is verbatim. Can you tell me about your hardness?
Yeah, I'm not that hard.
So how malleable and ductile are you?
I'm actually not very malleable or very ductile. It's one of my, weak points.
It's okay.
Exactly, yeah.
So I think that wraps up everything. Can you explain anything else?
Well, just a little quick, fun fact about, dry ice, me. I'm non-flammable, and I may or may not be acidic.
Hey, welcome back to our segment. This is the after show. You guys got to hear from Ice Cube and Dry Ice, but this time we're going to take them up to see what's really on the inside. So to start things off, guys, I want to know what your structure is.
My structure, so I'm cool with it, is a tetrahedral with Ben, and when I'm with other H2O molecules, I form a hexagon.
And how about you, Dry Ice?
Yeah, my structure is pretty linear, so, got a kind of one of these there, linear, you know what I'm talking about? Maybe one of these, up and down, linear.
Alright, next thing. I want to know the type of bond you have, like the bond type.
I'm a covalent polar.
Yeah, I'm a non-polar covalent.
Nice. Alright. Can you guys state the electronegativity of the constituent atoms and how the difference in electronegativity between particles characterize your guys' bond type?
Well, my hydrogen atoms have a 2.1, but my oxygen has a 3.5, creating a 1.4, which would make me polar, but I have two sets of lone pairs, creating my bent shape.
See.
Yes. The difference between electronegativities of my constituent atoms is 1, so that makes me nonpolar covalent and linear.
Thank you. Now, I'm going to throw this out here. Can you guys discuss how the valence are treated, transferred, or shared equally or unequally?
Well, oxygen shares its electrons with both hydrogens, but it still has some valence electrons left over, creating its two sets of lone pairs.
Yes, the valence electrons between my bonds are shared equally between each oxygen atom.
Alright guys, so I know you guys are both covalent molecules, but what I want to know is what's the direction of your guys' dipole?
My direction is from hydrogen to oxygen at a dipole moment of 1.85, and I also have two lone pairs.
So does that makes you polar, right?
Yes.
And how about you, Dry Ice?
What's a dipole?
You don't have a dipole, bro?
Hello? Oh, he doesn't have the dipole. Oh, sorry about that.
Oh, it's okay.
I mean, I have a pretty fly pole, if you know what I mean.
So, on to our next question, let's discuss the type of intermolecular forces that are in your solid.
Well, I have a hydrogen bond. I'm the strongest. I hit the gym on the daily.
Yeah, I have a London dispersion bond. I'm pretty weak. I'm sad.
Yeah, well, you should be. That's something to be really sad about.
Yeah. Alright, this is the end of our segment. Thank you for watching. It's been great talking to Ice Cube and
Dry Ice, I'm gonna send you over to, Jordan Neal Clark.
Which ice will gain your affection? Will it be Ice Cube, whose crystalline hexagonal structure, accompanied by a strong intermolecular force known as a hydrogen bond, creates a low melting point, but gives this ice the strange ability to float on its liquid form? Or will it be the even colder dry ice, whose linear dual lone pair structure not only allows its orbitals to be hybridized, but also gives off a very weak London dispersion bond? Nevertheless, we still haven't seen a molecular solid quite sublime as he is. So which molecular solid is right for you? We'll let you decide that either next time you decide to study, or you can tune in next time in Ice Ice Baby.